Hey, AP Chemistry students, I wanted to show you a shortcut when it comes to solving equilibrium problems, especially because this shortcut is what I would expect to happen on the AP Chemistry exam. Now, it's a possibility that they're going to ask you to work out the quadratic equation, but that's unlikely. I think this shortcut is what you can expect to do for any equilibrium questions that you might need to solve on the AP Chemistry exam. So I want to show you the situation, okay? This is going to look rather similar to ones that you've already worked in our notes, all right? But one big key difference, okay? So I call this the shortcut of when you have a small x or something like that. The key with this works, and this only works if your KC is incredibly tiny. So check out my KC there, all right? So I'm going to pull up my annotating tools here. Check out how small that KC is, okay? Now, here's the big thing. It needs to be small compared to your initial concentrations to be able for this shortcut to work. My rule of thumb is if the difference is a 10 to the negative 4. So if it's at least a 10 to the negative 4 difference between your concentrations and your KC, then you can use the shortcut. A lot of other teachers and the textbooks often will say if it's going to make a less than 5% difference. Problem with that is you have to kind of do like a calculation ahead of time to know if you can skip a calculation. So yeah, I don't think it's like, it has to be that cumbersome. So I'm going to do a small x approximation here. And the reason I can do it is because my KC is 10 to the negative 7. This would be 3 times 10 to the negative 1. This would be 1 times 10 to the negative 1. Even if this was like negative 2 or like it wouldn't matter. As long as there's at least a 10 to the negative 4 difference between the numbers, you are okay in taking the shortcut. If it's only a 10 to the negative 3, this would be when I would question, big old question marks around this one. That's right on the edge. 10 to the negative 2 difference, no, I wouldn't do it at all. Okay. But 10 to the negative 3 difference, maybe. I would definitely come back at the end and check that it only made a 5% or less difference. So beware there. Okay. So we're going to begin working this like we would the others. So I have 0.3, and I'm keeping my sig digs there, 0.300 minus x, 0.100 minus x, and then this is 2x, okay? And I'm going to write my KC expression. Concentration of C squared over concentration of A and concentration of B, okay? And I know what KC is. I was given my KC. I know what these are. These are going to have X's. Now, here's how we would originally write this, right? We're going to say that we're going to put that there, we're going to put that there, and we're going to put that there. Here's what we can do, okay? And you need to make note of this when you do this. You need to communicate because we on the test, as we grade, we need to know what you are doing, not what we think you're doing, because we don't want to put thoughts in your head. And unfortunately, if we have to put thoughts in your head, we're normally going to be like, no, I don't give any points for that. So be careful. Show this, okay? I would make some assumption, like you could say because KC is small, let 3.00 minus x be approximately 0.300 and 0.100 minus x be approximately, I know you love my handwriting, I know. Okay, but that's why I'm saying it out loud as I'm going. Okay, so in other words, on those two, I'm ignoring the x's. I don't want to ignore the x in my product or I'll have no x's to solve for, and that defeats the whole purpose, okay? So here's my new expression for KC. I'm going to plug in my KC, so 9.2 times 10 to the negative 7 equals C is 2x because it was 2x there, okay? And that still also gets squared. So note that not when we have a coefficient, not only does it change the amount of the x, it changes the I guess square or cube, the exponent, right? Yeah, it does. I've told you that. Just most students don't let that soak in. So soak it in, okay? Anyway, here's my new numbers here. 0.3, I'm losing the sig digs, I know, but I'll be sure I put them back at the end. 0.1. Look at how much simpler this math is going to be. I'm going to multiply those. I'm going to multiply all of that. What do I have left on this side? Okay, now be careful. Students, pay attention. Look out. Watch out. Warning. Danger, Will Robinson. Danger. What is 2x squared? 2x squared is not 2x squared. 2x squared is 4x squared. Yeah, so be careful. Okay, and then you'd have whatever that number is there. Okay, so I'm done showing you the shortcut. That's the shortcut. Instead of writing these with the x's and having them in the denominator and needing to use FOIL and then multiply and then use the quadratic equation, I get to assume these amount I would subtract from here and possibly add if there was a condition where I knew like my product amounts and I was solving for reactant amounts. Okay. Anywhere I'd subtract x or add x, I could ignore. Where x is by itself, I do not want to ignore it. That's the x I'm solving for. Okay. So I would obviously first, remember PEMDAS, okay? We're going to first divide by 4, then take the square root of both sides. There's your x. Now, warning, 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 warning. Whatever x is, and be sure you go to 3 significant digits in your molarity, your answer to C is going to be double that. Now, often we made the assumption, and so it would be all right if you still said actually B is still 0.1000 and A is still 0.3000 because we made the assumption. That usually works, okay? What if you want to be like certain and subtract your x? Okay, go for it. I've seen this in a problem once in a textbook where you do this and the textbook answers actually subtracted from x, but their answer for B, if you will, was 0.099999973. Well, by the time you round to your 3 sig digs, what are you left with? The exact same thing you started with. So if you do this approximation and it's a valid approximation to make, it really should not make much difference at all up there. All right, that's what I wanted to show you. Again, when can you use this? If KC is like 10,000 times smaller, okay? So 10 to the 4, 10,000 times smaller than your starting concentrations, then you can make this assumption easy. If it's only 1,000 times smaller, you're right on the borderline. Be careful, proceed with caution. If it's only 100 times smaller, don't. If KC is not even a decimal, if it's a large number like 49, you can't. Okay, you just can't. All right, that's what I wanted to show you. That's what you can do to make the math easier. I expect this is what is going to be expected of you on the AP exam, other than like not having to do the quadratic equation. I do not believe that the likelihood, I can't say it's an impossibility, the likelihood of that is incredibly low. So figure out how to do the shortcut. Don't forget to tell us when you do the shortcut. Good luck.